So welcome. So we shall solve this is CAI paper, October number 2007, M1. 7 questions are there. We shall solve all the 7 questions. Starting with the first question, a car of mass 900 kgs. So the mass is equal to 900 kgs. Is a constant force with a rate of P kilowatt, and the resistance of the motion, the backward force is 550 newtons. Given that the acceleration is 0.2 meter per second square and the velocity is 30 meters per second, find the value of v. So the formula is forward force minus backward force is equal to ma minus backward force is equal to ma. The forward force is our driving force minus backward force is 550, m is 900 times a is 0.2. Driving force can also be written as P minus V is equal to 180 plus 550. P we have to find it out in kilowatts, so 30 is equal to 730. P is equal to 730 times 30 divided by 1000 by, because I wanted kilowatt. So this answer will be 21.9. Coming to question number 2, a particle is projected vertically up from a point with an initial speed 12.5 meters per second. At the same time or the same instant, another particle is released from rest at a point 10 meters vertically above A. Find the height at which they meet. So I draw a straight line. So where is a straight line? This is a straight line. From here, one particle at the bottom, one particle is released with the speed of, or projected with the speed of 12 meters per second. From the top, a particle is dropped with initial velocity 0. So they may meet somewhere in the middle. So what I can do it is, this falls a particular height, then the down particle rises a particular height, then both meet at one particular point. He is asking what is the height above O. Where is O? O is at the base. So this is A, this is B. So he is asking what is the distance OA. H is equal to how much? And the total distance is nothing but what it has been given, 10 meters. So this has to be 10 minus h. So we have to find it out, the two different things. So let us consider the first particle. The first particle I am considering in green color, right? So let the green color, initial velocity is equal to 12.5. Let me write it as A for the particle A. Initial velocity is 12.5 meters per second. Acceleration due to gravity is going upwards, minus g. Then I am going to use the time. I don't know, so let it be equal to time. So I use S is equal to, or S1 is equal to ut plus half at square. From there, H is equal to U is 12.5 t plus half A is minus g t square. So H is equal to 12.5 t minus 5 t square. G value is 10. I got H is equal to this. Now coming to the second particle I denoted in red color. So the particle B, let it be particle Q, because we have already done that, right? Particle Q. So initial velocity is 0, acceleration is plus g because it is falling down, time it falls for the same time, and distance is 10 minus h. So I use S is equal to ut plus half at square. So S is 10 minus h is equal to 0 times t plus half times A is g t square. So 10 minus h is equal to 5t square. So I got two equations, so I can solve those two equations. What I can do, that one is the second equation is this one, and the first equation is this one. So 10 minus h is 12.5 t minus 5t square is equal to 5t square. So from there I get 10 minus 12.5t plus 5t square is equal to 5t square. 5t square gets cancels. Then I'll be getting it out. 10 minus 12.5t is equal to 0. 12.5t is equal to 10. T is equal to, I get 10 divided by 12.5, which gives me time is equal to 0.8 seconds. But I want h, right? So formula for h is nothing but what we got is 12.5t minus 5t square. 12.5t minus 5t square. 12.5t is 0.8 minus 5 times 0.8 square. Simplify that, we should be getting 6.8 meters. Question number 3. This diagram, find the values of f and theta. So first resolve f. So I resolve one horizontally and vertically down. So horizontal will become f cos theta, the vertical will become f sin theta. Now I think so it should be in equilibrium. So left side force should be equal to the right side force, upward force should be equal to the downward force. So upward force should be equal to downward force. So f sin theta is equal to 4. Similarly, the next one is left side force should be equal to right side force. So I get f cos theta is equal to 7. Then what do? I divide both. F sin theta divided by f cos theta is equal to 4 upon 7. So from there, tan theta is equal to 4 upon 7. Theta is equal to tan inverse 4 upon 7, which is 29.7 degrees. What else is being asking? Find f. So substitute f as theta value in this one, in f cos theta. So I get as f cos theta is equal to 7. F cos 29.7 is equal to 7. From there, f is equal to 8.06. The force of magnitude 7 newtons is now removed. State the magnitude and the direction of the resultant of the two forces. Magnitude of 7 is removed. Okay, so what is he asking? What will be the magnitude and the direction of the resultant of the remaining two forces? Now, because we assume that the body was in equilibrium, because of F and 4 newtons and 7 newtons, all the three together, the body was in equilibrium. Now what's happening is, if this 7 newtons is removed it off, means this 7 newtons was balancing, this was doing the balancing act. If 7 newtons was removed it out, so the resultant would have been 7 newtons. Therefore we have to resultant would have been, or resultant would have been 7 newtons, and it is balancing that one. It is maintaining the body in the equilibrium, So if 7 newtons is removed, so obviously the body will be moving in the opposite direction of the 7 newtons. So therefore we can write that the resultant is 7 newtons and direction is opposite to the direction of direction of 7 newtons. Similarly, for example, one more extension for this, though it has not been asked. If 4 newtons is removed, so what will happen is we have F, 4 newtons and 7 newtons. So these three, if 4 newtons would have been removed, so the resultant will be 4 newtons because it would have been moved in that direction. So resultant is 4 newtons and direction is opposite of 4 newtons. So depends. So if at all 7 newtons is removed, the resultant will be 7 newtons. If 4 newtons is removed, the resultant will be 4 newtons. Now question number 4. The diagram shows the vertical cross section of a surface. A and B are 2 points of the cross section. A is 5 meters higher. Particle B of mass 0.35 passes through A with the speed 7. Moving towards the surface B, assume that there is no resistance to motion, find the speed. So we use total work done is equal to delta KE plus delta PE plus work done against friction. TWD means total work done. WDF, work done against friction. Total work done is 0 because we are not pulling it. Delta KE means final kinetic energy. We have to find it out, the final kinetic energy. Half m is how much? 0.35 v square minus initial kinetic energy. Half m is 0.35 minus times 7 square plus final potential energy is 0, initial potential energy m, g is 10, h is 5 plus work done against friction. Because there is no resistance, work done against friction is also equal to 0. So what is this one? This is final kinetic energy. The next one was initial kinetic energy, and this one was final potential energy, and this one is initial potential energy. Now from there I can equate it out and get that the values. So what do I get it out over there? Half 0.535 times v square is equal to 1 upon 2 0.35 times 7 square plus 0.35 times 10 times 5. From there I get the value of V as 12.2 meters per second. Assuming instead there is a resistance of motion that the particle reaches with 11 meters per second, find the work done by this resistance of motion. So there is a resistance of motion and the particle will be reaching with, what is the thing? It's 11 meters per second. So what is the work done by this resistance? Okay, so what am I going to do? I am going to take the same formula over here, paste that, then erase this. Okay, so total work done is going to be 0. Delta K is half times 0.35 times 11 square because it is reaching with 11. 0.35 times 7 square plus final kinetic energy is 0 and same 0.35 times 10 times 5 plus work done against friction. So that work done may be W. So we have to find it out, this W. So W value will become 2 now. 0.35 times 10 times 5 minus 1 by 2 times 0.35 times 11 square plus 1 upon 2 times 0.35 times 7 square. Simplify that, it should be equal to 4.9 joules. Question number 5. A ring of mass 4 kgs. And tension T is balanced with the magnitude force of a magnitude tension T acting at 60 degrees. So draw this one. The T is acting downwards. So this has to be T cos 60 and perpendicular will be t sine 60. Apart from that, the weight also will be acting downwards, which is 4g. 4g also will be acting, and what will be acting upwards? A friction will be acting upwards. Frictional force. The normal reaction, and the normal reaction is denoted by, what is that normal reaction? He told that the normal reaction R. This is R. Find R and F in terms of T. So we can see that R is equal to T sine 60 because it is in equilibrium. Then F should be equal to 4g plus T cos 60. That is, F is equal to 40 plus T cos 60. Then the coefficient of friction is 0.7. Find the value of T for which the ring is about to slip. So we know that F is equal to mu R. So 40 plus T cos 60 should be equal to mu is 0.7, R is T sine 60. That's it. So from there we can get it out. The value of T is equal to 40 divided by 0.7 sine 60 minus cos 60. That should be giving me 377. Question number 6. A man walks in a straight line A to B with a constant acceleration 0.4 A to B. A to B. Then speed at A is 1.8 meters per second. Speed at B is 2.2 meters per second. Find the time taken for the man to travel this distance. Acceleration is equal to 0.004 meter per second square. Find the time taken. So V is equal to U plus AT. So V is 2.2 is equal to U is 1.8, A is 0.004 times T. From there I get the value of T as 100 seconds. Now I want to know the distance. Then S is equal to, I can use, or what I can use is, he's asking the time and the distance, right? So time I have found it out. The distance, for finding the distance, what I can do it is, I can use the formula V square is equal to U square plus 2AS. So V square, which is 2.2 square, is equal to 1.8 square plus 2 times A is 0.004 times S. If I simplify from there S, I get 200 meters. Now coming to the woman cyclist, leaves A at the same instant as man. She starts from rest and travels in the straight line B, reaching B at the same instant. So she is taking the same time. At a time t seconds after leaving the cyclist, the velocity is k times 200t minus t square. Find the value of k and find the speed of this one. So for the woman, time is going to be the same, 100 seconds. Distance is going to be the same, 200 meters. So the velocity, the formula for the velocity has been given as k times 200t minus t square. K times 200t minus t square. So if I do the integration of this one, velocity means ds upon dt, k times 200t minus t square, move this dt to the other side, and there is that division. So I get it out distance, but the distance should be equal to, between the limits 0 to 100, they should be equal to 200 is equal to k times 200t squared by 2 minus t cubed by 3 from the limits 0 to 100. So plug in there, 200 is equal to k times 100 times 100 square minus 100 cubed by 3 minus 0 minus 0. So from there I get the value of k as 0.003. Next, what is he asking? Find the cyclist speed of the cyclist B. So speed also we have to find it out at B. So we know the velocity is equal to k times 0.303 times 200t minus t square. Now at t, so substitute 100, so 0.003 times 200 times 100 minus 100 square. So this should become 3 meters per second. Next, sketch using the same axis the velocity time graphs for the man's motion and the woman's motion. So we have to sketch the graph for man's motion and the woman's motion. So the man is starting with 1.8 and reaching with 2.2 with a constant acceleration 0.04 and taking 100 seconds. 0, let it be 100. At the speed it was 1.8, this point is 1.8, maybe this point is 2.2. So he's starting with 1.8 and reaching with 2.2. So the constant acceleration. That is for man. Now for the woman. She is also starting with 200. She's also starting from rest 0, but she's going with 200t minus t square. 200t minus t square. For the woman, the formula is k is 0.003 times 200t minus t square. Minus t square, so it should be a parabola, but it should be upside down. It should be an upside down, starting from 0, 0, but we should know somewhat. It is 0.003 times 200t minus t square. So first of all, I'll try to find it out the acceleration, which is 0.003 times 200 minus 2t. So when is the maximum point? Because it's a parabola, right? So acceleration derivative should be equal to 0. 200 minus 2t is equal to 0. 2t is equal to 200. T is equal to 100. At 100, it's going to be the maximum speed. Then what are the points it will reach? What is 0? The x-axis. At points it will intersect the time axis. So means we should be equal to 0. So 200t minus t square is equal to 0. So t common, 200 minus t is equal to 0. So t is equal to 0, t is equal to 200. So it is 0 at 200 also. So what am I going to do it is, I'm going to shift this 100 somewhere over here and write 200, and the velocity is 3, right? The velocity is 3. So I draw a parabola having a maximum value of 3 at 100. Okay, so this is for the woman. The black color is for the woman. So for the man, let us use the blue color. He starts with 1.8 and reaches the 100 seconds with 2.2. So this should be the velocity time graph. Okay. So right over here, time in seconds, and this is velocity in meters per second. Question number 7. A rough inclined plane of length 65 meters is fixed with one end at a height of 16 meters above the other. The particles P and Q are attached to the ends of a light inextensible string which passes over a smooth pulley at the top of the plane. The particle P is held at rest and Q hangs vertically below the pulley. The system is released from rest. The P starts to move up. Draw a diagram showing the forces acting on P during the motion. So forces acting on P. So P's mass is 0.13. So first 0.13 G, there will be a parallel force. If this angle is theta, so it will be 0.13 G sine theta. So what I will do is I will draw a bigger diagram. I will magnify the diagram over here. So 0.13 G is acting vertically down, then downwards along the slope it will be 0.13 G sine theta, this angle is theta, then perpendicular to that one will be 0.13 G cos theta, and it is balanced by normal reaction R, and there is a tension T towards the pulley, and for this the weight is 0.11 G, that is for Q also. Show that T minus F is greater than 0.32. And is there any friction? Rough inclined plane, so it is trying to move up, there should be a friction which is moving downwards, mu R. Show that T minus F is greater than 0.32, where T is the tension in the string, F is the magnitude of the frictional forces. So first thing is, we see that we just draw a right angle triangle. So this one was 65, height is 16, so by Pythagoras theorem this is 63, so sine theta is equal to 16 by 65, and cos theta will become 63 upon 65. So now for the P, what are the forces? Tension is a forward force, minus backward force is a frictional force, minus 0.13 G sine theta. Sine theta is this one, 16 upon 65. This should be greater than 0 because it is about to move. So from there, T minus F is greater than 0.13 G times 16 upon 65. T minus F is greater than 0.32. The force should be greater than 0, then only it will be able to move. So therefore I have used greater than 0. Next part, what is he asking? The coefficient of friction is 0.6. Find the acceleration. The coefficient of friction is 0.6. Find the acceleration of the particle. So now we can see from the diagram that R is balanced by 0.313 G cos theta. So first I find R value. R is 0.13 G cos theta. So 0.13 G is 10, cos theta is 63 upon 65. Then we know that F is equal to mu R. Mu is 0.6. This value, let me write it as 1.26 times 1.26. This value I get it as 0.756. Now I know that forward force minus backward force is equal to MA. Forward force minus backward force is equal to MA. Forward force was tension, minus backward force was my frictional force, minus 0.32 is equal to MA. M is 0.13 A. This is for P. Okay, so forward force minus frictional force minus 0.32. So what is the 0.32? If you don't understand that, let me write it out once again. Forward force is the tension, minus backward force is friction, minus 0.13 G sine theta is equal to MA for P. So tension, that is one equation. Then for Q, what is another equation? The forward force is nothing but what? 0.11 G minus backward force is tension is equal to 0.11 A. Now add these two equations. Tension cancels. What do I get? 0.11 G minus frictional force. Just now we got the frictional force was 0.756 minus 0.13 G sine theta is 16 upon 65 is equal to 0.24 A. From here, A value I get it as 0.1 meter per second square. That is answer. So I use forward force minus backward force is equal to MA for P and for Q. That's it. That completes the paper. See you in the next paper.